Okay, so this video is going to cover learning objectives 2 and 3. So probably just learning objective 2 in this video, which is to be able to use a log transformation to calculate growth rate. So kind of an interesting picture here. So this shows the experience of the U.S. economy from 1900 to about 2015. So what we have on the vertical axis here is per capita income in thousands of 2009 US dollars. So we're looking at basically income per person in the US. And it's roughly speaking adjusted for inflation. Now we'll understand better exactly what that means in the next week, in week 2, when we discuss measurement. But for right now, just understand that this numbers are adjusted for inflation. So you can kind of compare to roughly what your income would be today if you had this much money. Now in 1900, the average person in the U.S. economy made $5,000 per year. That was the average income. Again, adjusted for inflation. So imagine that you had $5,000 right now per year to live on. And some of you may have that income, right? You have a pretty good sense of what your standard of living is, and that was the average standard of living in 1900. Now compare that to 2015. If we went all the way to 2022, it's actually above this. We're closer to $65,000 would be the average income of someone in the U.S. economy. So that's a very, very large increase in your standard of living, right? Over the course of over 100 years, our incomes have gone up significantly. So that's the economic growth part we were just discussing. Macroeconomists are trying to understand how has our economy grown so quickly over such a short period of time, relatively short period of time, right? And will we be able to continue that growth experience into the future? So that's the first thing we notice on the graph, right? Then the business cycle part is we see all these ups and downs. And I'll circle the Great Depression and World War II because those are the biggest ups and downs that we see. And you see other little ups and downs. Those are referred to as business cycles. So that's a good picture to look at to kind of understand what macroeconomists are concerned about, is trying to explain what's going on in this picture. That's the broad strokes. Okay, so what is the growth rate? So I'm gonna call the growth rate in period T. So T would be a year. So if I gave you an example, maybe I want to know the growth rate of income in 2022, for example, right? So T is just the period that I'm referring to. So what was the growth rate this year, right? Or between 2 years. So typically we do a growth rate as a percent change in a variable, right? So percent change. And so what that's going to typically look like, right? So let's say that Y is income. And I want to study how income has changed between 2 periods. Well, what I would do is I would take the value of Y in period T, subtract the value of Y in the previous period, and divide by the value of Y in that previous period, right? That's a growth rate. So let's say Y in, let's say 2022, that's my T, was 110. I'll make this easy on us. And Y in T minus 1 was 2021. So notice here, T is equal to 2022. It's just a number, right? So don't worry too much about the subscripts. We're not gonna futz around with that too much. Just kind of a way for me to write it down cleanly here, right? So if that was 110 in 2022, 100 in 2021, the growth rate in 2022 would be 110 minus 100 divided by 100, which is going to be 0.1. So it'll be 10 over 100, which is equal to 0.1 or as we often say, that's a 10% growth rate. So income, in this case, Y, we're calling it, increased by 10% from 2021 to 2022. So despite all of the subscripts and letters and all that stuff, growth rate is pretty easy to calculate, right? Simply the percent change in the variable. Now that's fine, right? So you've all done growth rates before. You know how to calculate the percent change in a variable. That's not going to cause anybody problems, and I wouldn't expect it to. Now there's kind of a neat trick that if you transform your data that you have at the beginning using this trick, it makes calculating the growth rates quite a bit easier. So I'm going to come back in the next video and we'll talk about how we can approximate the growth rate using a nifty trick called the log